In this video, we will be discussing the three most basic trigonometric ratios, being sine, cosine, and tangent. So first, we have written for you the ratio of sine is the side opposite over adjacent. So in this case, it's BC over AB. And in order to find angle A, if I'm given the side lengths instead, I take the inverse sine. So on most of your calculators, it's going to be a second or a shift button, and then you'll press the sine button. So it should be a little script above the sine button, or on some other calculators you might have to press the sine button a couple of times. And it would be the same for cosine versus cosine inverse and tangent inverse. The only difference here is cosine is a different ratio. So instead of opposite over hypotenuse, it's adjacent over hypotenuse, and the tangent is the side adjacent, the side opposite over the side adjacent. So I have those sides labeled for you, and I have both the trig functions and the inverse trig functions labeled. So we're going to work out just a handful of examples with different given information. So let's look at example 1. These directions for this example just say set up the three trig functions for angle A. So all I want to do is write the sine of angle A and figure out what that equals, the cosine of angle A, and the tangent of angle A. So these ratios, these fractions that I'm setting up, they would be different if I was talking about angle B. So since I'm talking about angle A, I'm going to label my opposite side, and I'm going to label my hypotenuse, which makes AC my adjacent side. And it's always helpful to write out, so toa. So sine is the opposite over hypotenuse, so the opposite here is 24, and the hypotenuse is 25. So sine of angle A is 24 over 25, which I can type into my calculator and get an approximate decimal here. It does equal exactly 0.96. If you are rounding, make sure to put the approximate symbol instead of an equal sign. So the cosine is adjacent over hypotenuse. So my adjacent side is 7 over 25, which equals exactly 0.28. And my tangent is opposite over adjacent, which is 24 over 7. And I'm going to round to 2 decimal places. So it is 3.43 approximately. So that would just be one type of problem where they ask you just for the ratios for you to set them up. Normally speaking, you're going to just leave them in fraction form unless they ask you to go ahead and round. A second type of equation using the trig functions would be if you were to solve for a missing side length. So looking at this problem, I want to look at my angle, and it's 60 degrees. So I want to figure out sine, toa, cosine, ca, and then tangent, toa. All right, what sides do I have, and what function am I going to use? So this is my hypotenuse, and I don't have my hypotenuse, so I can actually go through and mark off the ones with H. So this means that I can't do sine and I can't do cosine. So maybe I can do tangent here. Well, this is the side opposite and this is the side adjacent. All right, and I do have the angle. So if I set up the tangent of angle 60, of that angle, which is 60 degrees, the tangent of 60 degrees equals x over 4. All right, so I've set up my trig function. Now I actually want to solve for x. So you just go about it a normal solving method. Since x is divided by 4, I want to multiply by 4 on both sides. These are going to cancel out. And x is going to equal exactly 4 times the tangent of 60. and my directions probably tell me to round to the nearest tenth, hundredth, or thousandth. So I'm going to type 4 tangent of 60, 4 times the tangent is 60, into my calculator. And I'm going to get x is approximately equal to 6.93. All right, so that is using a trig function to find a missing side. And now let's look at another example to find a missing angle. All right, if I have all of the side lengths and it asks me, let's find the measure of angle angle U and angle W. We already have angle V. We want to use some trig functions. So since we have all of the sides, it doesn't matter which ones you set up. So I'll set up a sine of, let's do angle U. All right, the sine of angle U is going to equal, remember, sine is opposite over hypotenuse. Opposite of angle U is 24, and the hypotenuse is 30. And this is where we're going to use the inverse. So if I take my sine inverse of 24 over 30, that's going to give me the measure of angle U. So into my calculator, I type in the sine inverse, which is typically going to be your second or your shift button for sine, and then you do 25 divided by 30. And you press enter, and you get angle U. The measure of angle U equals about 53.13 degrees. Okay, so since this equals about 53 degrees, you can take the 53 degrees away from 90, and that should give you angle W. Instead, I'll just use another trig function for more practice to set up angle W. So I'll use tangent. All right, if I take the tangent of angle W, tangent of W, that's going to be TOA. All right, so the opposite of angle W is 18, and the adjacent of angle W is 24. So that means when I take tangent inverse, it'll be of 18/24. You can reduce those fractions when you plug them into the calculator if you want. So it would be second tan of 18 divided by 24, or of 3/8. Which is approximately going to equal 36.87 degrees. And if you were to subtract that from 90, you would get the 53 you got before. All right, now moving on to our final problem here, it's going to say solve the right triangle. That means we want to find any missing sides and any missing angles. So we're going to use everything that we just learned, as well as the Pythagorean theorem, and the fact that the interior angles of a triangle add to 180 degrees. So I'm going to solve this triangle. First I want to list out everything that I need to figure out. HJ, I need to find the length of HJ, and I need to find the measure of angle G, and I need to find the measure of angle J as well. So, first and foremost, I've got two sides of a right triangle, so I just have a feeling like I want to use the Pythagorean theorem. So I'm going to start out with a squared plus b squared equals c squared. All right, it's a right triangle, so I can use that. 14 squared. I don't have the other side. All right, so I'm filling in one piece at a time here. Okay, so 14 squared is 196. 16 squared is 256. When you subtract, b squared equals 60. If you were to take the square root, you might be able to leave it like that. If you reduce the radical, that breaks into radical 4 times radical 15. So the true exact answer of your b there, or your hj, is 2 radical 15, but likely it's going to go ahead and say round to the nearest tenth, so we'll say 7.7 here. So hj equals approximately 7.7. Now I'm going to throw it out there that since you found this value and you did round, when you're finding one of the angles, don't use your rounded value because you're going to approximate and approximate. Alright, so it's just going to make angle G and angle J less accurate. So we want to use 14 and 16. So if I look at the measure of angle G, I want to use this side, which is the hypotenuse, and according to angle G, this is the adjacent side. 14 is the adjacent side. So if I look at ca, it's supposed to be an H, toa, which trig function uses adjacent and hypotenuse? So adjacent, hypotenuse. Alright, so cosine. So if I set up cosine of angle G equals 14 over 16. This means if I take cosine inverse of 14 over 16, that's going to give me the measure of angle G. So into my calculator, I'm going to type in second cosine 14 divided by 16, and I will get G approximately equals 28.96 degrees. Okay, so if this is 28.96, I can take away from 90 degrees for my two acute angles here for angle G and angle J. Those must add to 90, since all three angles must add to 180. I can take 28.96 away from it. So the measure of angle J here is going to equal 61.04 degrees. Okay, so if I have solved this correctly, I have all 6 values, so all 3 sides and all 3 angles, which I do. Alright, if you guys have any questions whatsoever, please feel free to see me before or after school. Trig functions are super important, especially once you move into pre-cal. You will see them on the ACT, and you will also start seeing right triangles everywhere and start to have an appreciation for buildings and bridges.